Here at Rutgers, CARTA and CBIM, we have created a collaborative and multidisciplinary program which is really unique. It combines cutting-edge science and technology, the brightest minds, and industrial connections. The Computational Biomedicine aspect of the program consists of clinical applications, preclinical applications, and neuromorphic computing.
Neuromorphic computing is the next big step towards biomimicry. It is important because we rely on that knowledge that has been accumulated over centuries, and we try to imitate that biological intelligence and bring it to intelligent machines.
The learning to humans is actually not simply learn the pattern, but it's actually building the model of the things in the world. What I'm doing is I want the machine learn this kind of models automatically without human supervision. And in the future, we will have some pretty general robots in our home, and that needs to have very general knowledge and that can have very general skills to do many different things.
Robotics also try to mimic humans' movement. We have more and more older people, and the aging problem become a global issue. And we can say maybe 30, even 40% of our population is going to be elderly people, and many of them may not be working by themselves, and then do need some kind of devices in the future. I'm closely working with the rehabilitation hospital here, and they are designing robot, and I'm also designing robot, and we were trying to help people from different aspects.
Another aspect of the program here at Rutgers is multimodal sensory analytics, and that entails machine learning, computer vision, and natural language processing.
I'm working on intelligent robotic manipulation, which is how to deal with objects that are unknown, objects that are placed in arbitrary locations, and objects that can be cluttered, and the robot needs to figure out independently, autonomously how to deal with these objects.
I focus my attention on multi-robot motion planning and multi-object manipulation tasks. What we do in terms of algorithmic robotics is that we design algorithms that make robots do smart things. We want to really make things work faster and better. I design algorithms to squeeze that little bit of extra performance of a system. As you can imagine, right, in today's environment, just to get 1-2% of better performance than the rest of your competition will make you a winner.
The third aspect of the program at Rutgers is modeling, which entails computer graphics, physics-based modeling, generative adversarial network-based methods, and biomechanical modeling.
There are many problems in robotics and biomechanics that are not easily solvable and for which analytical models don't exist. Oftentimes, it is very difficult to perform lots of experiments on the robot because it can damage the robot, or the particular action may not be possible to replicate in laboratory settings. And so physics simulation is an easy way to learn efficient policies before trying them on the real hardware. That's where I come in, and I actually look at the full spectrum of problems to explore this different alternative.
Here at Rutgers, we have great sponsors who provide funding and support. Collaboratively, we provide solutions and the greatest young minds.
I'm collaborating with some of the leading chip manufacturers in the world, and there are also companies like special effects industries and video game industries that are interested in these technologies also.
I've actually started working with industry quite closely. Currently, I'm actually leading a industrial project working with a recycling company that they want to essentially automate many of their product lines.
I think maybe the unique thing about our research is that we are being at the intersection of industry and academia. So what we are trying to do is solve real-world projects. So our projects, most of them are funded by companies that are really interested in getting these problems solved. And at the same time, we are using the latest technologies in academia that we are trying to develop and make them more efficient in practice.
Rutgers gave me the opportunity to work on both technology and medicine. And CBIM provided me the opportunity to access technology side. I'm working with a lot of talent, PhD and master student to develop robots.
Some of our work have been picked up and recognized by the Robotics Society. They are being recognized as candidates for Best Paper Awards.
We are presenting at IROS this year a paper that shows how a neuromorphic approach can be as accurate as a more conservative technology such as G-mapping, while at the same time it is 100 times more efficient when it comes to energy.
I came to Rutgers because of the faculty here. They're very strong in AI and specifically computer vision.
Rutgers has good faculty in machine learning and computer vision, which I wanna do research in.
So I came to Rutgers because of the good faculties here, the beautiful environment here.
We've created a collaborative and multidisciplinary program which is really unique. We combine cutting-edge science and technology, the brightest minds, and industry connections. Here at Rutgers, we create the future.